Hi all, we're Team Ask and we will be presenting on machine-generated actions for sound event classification. Sound event classification is the task of identifying active events in audio. We want to automatically identify actions for audio which can be beneficial to sound event classification tasks. This is significant because automatically generating action information will eliminate the need for expensive human annotation. Traditional machine learning approaches for sound event classification use MFCCs, log-mel spectrograms, and audio embeddings. Recently, Elizalde et al. Showed that explicitly including crowdsourced ratings about actions producing an event can help generalization ability of machine learning models for sound event classification. Actions here represent the physical properties of sound, such as rotating and dripping, whereas sound events are the actual event described by a sound, such as birds chirping or raining. We use deep learning models to automatically generate action vectors as seen on the right. We compare our generated action vectors with the human annotated ones by measuring improvements in sound event classification task. For our experiments, we use the ESC50 dataset for both training and testing the action vector generation as well as the sound event classification. We use the results on sound event classification as our baseline. State-of-the-art OpenL3 audio embeddings concatenated with the crowdsourced action vectors resulted in an 8% increase in accuracy compared to just using audio embeddings. We use two approaches for generating action vectors. In the first approach, audio embeddings are used to train a multi-layer perceptron to produce normalized scores for each action class. In the second approach, we fine-tune a pre-trained audio neural network, or PAN, to produce action scores. The action vectors generated by these models are used to train a MLP to evaluate their performance on sound event classification. We use the same architecture and hyperparameters as Elizalde et al. To isolate the effect of using different input representations. We run each experiment 5 times and report the mean. And from the table here we can see that concatenating audio embeddings with the vectors, generated action vectors, results in an increase in sound event classification performance, suggesting that our generated action vectors actually may carry additional useful information. While comparing the performance of the action vectors generated by the MLP versus the PAN, we found that the PAN-generated action vectors perform better in isolation and in conjunction with the audio embeddings. Interestingly, both outperform the accuracy obtained by using log-mel spectrograms, as reported by Elizalde et al. To compare our MLP-generated action vectors versus the PAN ones, we look at the heat map. Actions here are along the x-axis and sound events are along the y-axis. The leftmost heat map corresponds to the true action vectors, and we hope to produce action vectors that are more similar to that. Taking a closer look at the heat map for generated action vectors, we observe some interesting differences. In the highlighted box, the action scores for braking are the action scores for braking, and we see that the PAN is able to capture information that the MLPs completely miss out on. Additionally, we see that the PAN's response for actions are brighter in general. For generating action vectors, we minimize the mean squared error, and we also computed the classification accuracy while predicting the top action as a proxy metric. Interestingly, we found that although the MLP achieved a lower MSE and a higher action classification accuracy, but in sound event classification, it performed worse. Furthermore, in the heat maps, we saw that infrequently annotated actions such as sizzling were not being captured adequately. So we chose the 10 actions based on highest frequency, which is seen in the graph here, and this resulted in 88% of the audio having at least one action, and these actions were used for generating action vectors and eventually for sound event classification. And we found that using these 10-dimensional generated action vectors actually preserved all the useful information when compared to the 20-dimensional counterparts. Now let us look at an example. So this clip actually, when the network was given information about just the audio embedding, it misclassified it as rain. Let us hear what it actually is. But when the network was provided with the PAN-generated action vectors, it actually ended up classifying it correctly as a helicopter. And that intuitively makes sense because the actions that are high for this sample are rotating and vibrating and blowing. To conclude, our work suggests that generating action vectors is a useful idea, and this idea drives our future work, in which we want to test our model that generates action vectors on other sound event datasets to explore the efficacy of generating these features. Thank you.